Okay, so we are doing the last topic in weathering and erosion. We have talked about wind, we have talked about water. Now we're finally going to start looking at glacial erosion and weathering. So the thing about glaciers is because it's made up of ice, it can pick up basically everything. Boulders, cobbles, pebbles, sand, silt, and clay. It can pick it all up with it. And with that in our knowledge bank now, know that the Earth has been through at least 5 major ice ages in history. One that even lasted over like 100 million years, though there have been a lot of minor ones since. And they happen about every 100,000 years. The last one that we had not too long ago, in the span of things, was 11,500 years ago. This information will be very good for you guys to remember in a couple of units from now, because we are going to start looking at Earth's history in a couple of units. All right, so like I said, I'll move myself over here. There are glaciers, right? And there are 2 types of glaciers. The first one is considered continental. These are the big ones that we typically think of. They cover entire continents. The second one we have are mountaintops. So here is a continental type glacier, and here is a mountain type glacier. So I would say like the continental type would be and one of the poles I'm trying, like Antarctica is a continental, whereas think of like Mount Everest probably has a big old glacier at the top of it. The thing with glaciers is they either advance or they retreat. Either one, especially continental. At the present, glaciers are currently retreating or melting due to global warming, which is a cyclic thing that does happen. Glaciers form up mountains when snow continuously falls without melting. All of that buildup of snow starts to pack more and more and then forms with ice. So my thought process is on this. Mountaintop glaciers form kind of like sandstone. You have all of the snow that's packing and packing and packing and packing and packing on top of each other. Doesn't have a time, like a second to melt. So as it compacts down, it turns into ice. It's a physics thing that goes on. And so all of this snow that keeps falling keeps packing and packing and cementing it together to form ice, which is considered a glacier. And as I stated a little bit ago, glaciers are retreating at this point in time. And when glaciers slowly advance, they collect particles along the way. As I said earlier, it's like nature's bulldozer. Glaciers slowly advance until they stop. There's not really a way to stop them unless they stop by themselves. And once they stop, they typically start to retreat. The point at which they stop and start retreating is called a moraine. This is denoted by a ridge or a big old pile of unsorted sediments or particles. They're not sorted because it's kind of like a bulldozer. It just pushes whatever it has until it stops, and then as it's backing up, you've got that line of unsorted stuff. The same thought process, only it's with ice. When glaciers melt and deposit material, it is unsorted, and it's called glacial till. I can't stress unsorted for glaciers enough. Anytime it says that you have unsorted sediments, unsorted particles, it's glacier. Sorted comes between water, regular water, and you have wind. That stuff will have sorted. Remember, vertical sorted, horizontal sorting. Here, for glaciers, it's all unsorted. Bulldozer, it just pushes whatever it has, drops it off, and backs off. So another thing about glaciers is sometimes chunks of them fall off from the main continental glacier, the main part of the glacier. And when one of those smaller parts that have broken off sits over land, it starts to push down on the land. So like the chunk is sitting on the land like this. And eventually, when all the glacier is retreated, you have sun, a little bit more warmth, so it melts. And these aren't tiny, tiny. When I'm saying big, I'm like Syracuse size. Like some of them can be that big. Some of them can be smaller like this. They leave large depressions in the ground. And when it melts, it is called a kettle lake. Another thing that we see, especially around here, near the golf course, glaciers leave deposits of sediments for that form long, thin hills called drumlins. These drumlins have one gentle side, here's my gentle side, and then a steep side, or a relatively steep side. And the really cool thing about these is they tell you which way the ice is flowing, which way the ice went. So the ice flow is towards the gentler side, the lee. In this way, it's the lee slope instead of the soft end. So this side, not the steep end, but the gentle side, that one is going to be the side that the ice has come from. So right here, this is where that glacier flow was going, right? And one of the things about these, they're pretty tall and thin, about 100 feet tall. Another big thing that is brought up when it comes to glaciers is called striations. Now these are not rocks, scratches in the bedrock that are formed when glaciers carry boulders and they drag along the bottom of the glacier, hitting that bedrock. Remember, it's like a big bulldozer. And if it's pushing these big boulders, the boulders are going to hit and abrade against whatever it's hitting and cause grooves or striations. And they scrape that bedrock. Other things, which I think are actually really, really cool, and if you go up to the Adirondacks, you see a bunch of them, is really huge boulders left in the middle of fields by glaciers. All these big boulders, they're called erratic. It's kind of like erratically placed. And then we have these long, narrow, winding ridges composed of stratified sand and gravel deposited by subglacial or end-glacial meltwater streams. And these are called eskers. Eskers look kind of like nature's fences, natural fences. That's when the glacier was over here and there was a stream underneath it. And it has the buildup and the deposition to form all of these little eskers. All right, last but not least, how can you tell that there has been a glacier that passed through a region? Okay, well, how can we tell about rivers? Rivers, if you remember our rules of V, they're shaped like V's. They go like this. They're just like V's, right? So you have a V-shaped valley. And glaciers, they form a U-shaped valley. Why? Because originally it might have looked like this, and the glacier came down through this little valley. And as the glacier goes down the valley, that ice is really, really heavy, and it pushes, it depresses out, and it forms that U shape. You can see the U-shaped valley right here, as opposed to the V-shaped valley right here. V, river, U is glacier. Okay? And that is it for the notes. If you have any questions, please don't hesitate to ask. And I hope you guys have a great day.